Chromatography. Today topic is chromatography. The chromatography is the separation of a mixture into individual components using a stationary phase and mobile phase. Here we have two phases and we separate the mixture. Types of chromatography. Here, based upon the nature of stationary and mobile phases, the types will be classified as gas solid chromatography, gas liquid chromatography, solid liquid chromatography, and liquid liquid chromatography. In solid liquid chromatography, the column chromatography, thin layer chromatography, high performance liquid chromatography are subtopics. And in liquid liquid chromatography, the paper partition chromatography and column chromatography are there. Based on the principle of separation, the chromatography is vary from each other, and the absorption chromatography and partition chromatography are separated and they are having different affinities. So in adsorption chromatography, when a mixture of compounds are dissolved in a phase which moves through a column of stationary phase, which is called as adsorption phase, they travel according to the affinity toward the stationary phase, which the molecule which has high affinity, they will pass fastly than the molecule having low affinity, and the compounds have more affinity towards and slower compounds which lesser affinity, they are travel slowly, and the compounds are separated. No two compounds have same affinity because each compound having different affinity by their molecular size, and it will be changes. A combination of stationary phase and mobile phase and other conditions. Examples of the adsorption separation is gas solid chromatography and thin layer chromatography, column chromatography, high performance liquid chromatography are the examples for the adsorption separation. And partition chromatography, here comes the partition chromatography. Partition chromatography is placed in when two immiscible liquids are present like water and alcohol. The two immiscible liquids are present, a mixture of solutes will be distributed according to their partition coefficient. The solutes will distributed, and a mixture of compounds are dissolved in mobile phase and passes through a column of liquid stationary phase. The component which is more soluble in stationary phase, that travels slower when compared to the components which are more soluble in mobile phase, that travels faster. And so that why with the compounds are separated by their partition coefficient. Here we can observe the difference. And a particular combination of stationary phase and mobile phase, the partition coefficient will be vary. The stationary phase and cannot be a liquid because the stationary phase changes by its partition coefficient. The solutes will be travel the from lower affinity to the higher affinity, so the liquid is not taken as stationary phase. Mobile phase is the liquid. Counter current extraction, the counter current extraction works on a principle. In this, two immiscible solvents like oil and water, which solvents flow in opposite direction. When we place the water and oil in a stationary phase, they are flow opposite direction. The solute mixture is distributed between the solvents depend upon their partition coefficient. Here the advantage is fresh solvent comes in contact and therefore the extraction is effective and the solute mixture separated into the individual compounds. The examples of partition principle separation is gas liquid chromatography, paper partition chromatography, and third one column partition chromatography. Based on the modes of chromatography, these are two types. They are normal phase chromatography and reverse phase chromatography. In normal phase chromatography, the stationary phase is polar and mobile phase is non-polar. So it is not used in pharmacy when compared to the reverse phase chromatography. Here, reverse phase chromatography, the stationary phase is non-polar and mobile phase is polar. So this reverse phase chromatography mostly used in pharmaceutical analysis. Here we can compare the normal and reverse phase mode, stationary phase, normal phase and reverse phase. The stationary phase is polar and reverse phase is non-polar. In mobile phase, the normal phase is non-polar and reverse phase is polar. The two are oppositely and compound eluted first and retained less. Non-polar, polar. We can example of stationary phase. Here the stationary phase example used in normal phase is silica gel and in reverse phase we use the stationary phase as ODS bonded phases. And these are the types of chromatography and also some other types of chromatographies are there. They are ion exchange chromatography. In this chromatography, the ions will exchange. The reversible exchange of ions will takes place like cation and anion we already known. And gel permeation chromatography means gel filtration, size extraction chromatography. This gel is used to separate the components of according to their molecular size. We can separate the components by using this gel filtration. And different gels are used for the molecular weight ranges to separate the components in a liquid. The stationary phase is porous matrix. The matrix is made up of cross-linked polystyrene. We already know polystyrene, polysaccharide gels are used. And most commonly used detector is refractometer detector in gel permeation chromatography. And the mechanism involved in gel permeation chromatography is separation process. Separation of steric and diffusion effects in pores of different gels, and this technique is used for the separation of proteins and enzymes for the components. The solution which contains more high affinity and low affinity molecules. And chiral chromatography also one type of chromatography. In this type of chromatography, the optical isomers like LIVO and dextroforms are separated by using the stationary phase and mobile phase. Thank you.